Professor, everything is ready?
So recording?
Yeah, just a minute. Recording, I have to start. Recording also I have started. Shall we proceed?
All your blessings, sir. All your blessing.
Thank you so much. Good evening, everyone. This is Dr. S. Nagarajan, Professor of Electrical Engineering and Principal of Surendra Institute of Engineering and Management, Siliguri, West Bengal. I am a moderator and host for today's panel discussion. On behalf of CWSIR and my own behalf, I extend a warm welcome to all the dignitaries of today's panel discussion on quantum technology. As usual, we'll start the session with prayer. Om Guru Brahma, Guru Vishnu, Guru Devo, Maheshwaraha, Guru Sakshat, Parabrahma, Dasmai Shri, Guruve Namaha. I bow down to that great Guru who is the essence of all living and non-living things, which pervades in the whole universe creation, moving and unmoving. To that benevolent Guru who showed me the true state of being, I bow down. Welcome every day with a smile. Look on the new day as another special gift from our Creator, another golden opportunity to complete what you were unable to finish yesterday. Be a self-starter. Let your first hour set the theme of success and positive action that is certain to echo through your entire day. Today will never happen again. Don't waste it with a false start or don't start at all. You are not born to fail. With that welcome note, I extend a very warm welcome to once again to all our chief guests and panelists. Let me introduce chief guest and panelist for all the dignitaries over here. Our chief guest of today's discussion, Professor M.M. Pan, former professor, former Provici, IGNO, and engineer Potsufero Sergi, Quantum Tech Russia, as a guest of honor for this wonderful panel discussion on quantum technology. I also welcome all the panelists for today's topic. Mr. R.K. Sharma, former Principal, Delhi Public School, Haryana, India. Professor Maitham Gale Yusuf, University of Al-Hadis, Iraq. Professor Warakamal History, King's Mongols University of Technology, North Bangkok. Professor Mutamaina Al-Ashari, Mandir University, Indonesia. And Mrs. Angelina Marcus, Langa Pacific Aviation Academy. Before moving on to the today's discussion, let me invite our General Secretary, Dr. Shruti Marwaga, CWSIR, to give an introductory talk about CWSIR and its activities. Ma'am, over to you.
Thank you, Professor Nagarajan. And it is a privilege for me to first of all introduce you to all of us. So this was Dr. Nagarajan, Principal, Surendra Engineering and Management Institute. And I feel privileged that you are among all of us such a renowned and such a learned person. It's been the second meeting I'm here and I've really learned a lot from you. Such a down-to-earth person, and I really thank you for hosting and moderating this meeting for all of us in such a sensitive and collaborative way. Thank you so much. Before we start up with this discussion, I would like to introduce CWSIR to all of us. CWSIR is one of the most renowned, world's most renowned organization working at the international level now. We all have a great privilege. I feel that all of us who are here today, we should be privileged that we are connected to CWSIR in one or the other way. It is an organization that was founded in 2019 in Gorakhpur, India, and the main intention and the incentive is to work and put human research and social research into action. It is very important when we talk about research that these kinds of things are implemented and put into social use. So I would like to thank Dr. Abhishek Pandey and Dr. Smita uh, Pandey, so that she has given us a chance to work in such an organization, to work with such an organization that is working for the welfare of the society. And we are trying to put our level best to make this all this research and its implementation fruitful to the society. Meetix is the talk that is a hub of all the brilliant speakers whom we meet here and we share views with. No gender bias, no sort of background bias. It is one and all, one for everybody around. As found, I would like to thank Dr. Smita, the founder of the organization, who has really given us an opportunity to be a part of this organization. And more than a founder, she's a person who's so down to earth and a mentor for all of us. And words are again not enough to describe Dr. Abhishek Pandey, who always stands behind all of us to give us unconditional support at every moment. And then I am really feeling very proud to introduce and welcome our chief guest today. I really want to say pradam, sir. I have heard lot about you, and Dr. Pandey really recognizes you as his guru, and you are a guru to all of us. And I really thank you a lot to spare your precious time for all of us. When I Google your name, it was really a sort of uh, you are a positive viral in at the internet. You are a person whom I really admire, and professional degree in physics, professional degree in law, and pro vice chancellor IGNU. We are privileged to have you here, sir, and we would like to hear a lot to learn, and we would like to learn a lot from you. He's a personality who has great interest in cyber law, trademarks, intellectual property rights, and he is a visiting scientist to research centers at national and international levels. So I would really welcome you, sir, and a great evening, and would like to hear from you. Over to you, Mr. Nagaranjan.
Yeah, thank you so much, ma'am. Before moving on to the today's panel discussion, let me start the session with a small preamble about quantum technology. Though I am an electrical professor, I have learned small thing about quantum technology. So as a moderator, it is my duty to give a small preamble about quantum technology, and let me start the session with that preamble. See, quantum technology is an emerging field of physics and engineering which relies on the principles of quantum physics, quantum computing, quantum sensors, quantum cryptography, quantum simulation, quantum metrology, and quantum imaging are all the examples of quantum technologies, where properties of quantum mechanics, especially quantum entanglement, quantum superposition, and quantum tunneling are important. According to John O. Newman's quantum technology is different from the determinist classical mechanics, which holds that the state is determined by values of two variables. He stated that quantum technology is determined by probabilities, and his explanation has been used to justify the technology's superiority. So he wanted to hear more about quantum technology from our chief guest and our panelists today. So with that, it is my duty to formally welcome and introduce the chief guest to the forum. It is my great privilege and honor introducing our honorable chief guest, Professor M.M. Pant, who had been an inspiration for many professionals. Professor M.M. Pant has promoted Planet EDU Private Limited as it is founder and chairman, along with a team of highly experienced and skilled professionals from education and training. A PhD in computational physics along with a professional law degree has been a practitioner in the field of law, IT-enabled education and IT implementation. Professor Pant has been the Pro-Vice Chancellor at Indira Gandhi National Open University and on the faculty at IIT Kanpur, the premier engineering institution in India, MLNR Engineering College, and on the faculty and visiting professor at University of Western Ontario, Canada. He has been a visiting scientist to research centers in Italy, England, Germany, and Sweden, and has delivered international lectures with about 80 published papers in history. We are really thankful to him for taking the time out of his busy schedule to attend today's session. The presence of such a great personality in our panel discussion is a blessing for all of us. We hope that the next generation professionals are able to seek a little guidance and imbibe something from his thoughts. I request Sir to enlighten us in his precious words once again. On behalf of CWSIR and my own behalf, I welcome Sir to start the session with his presidential address. Sir, over to you.
So thank you, Professor Nagarajan, for those initial words, and Shruti for the comments that she made. And of course, first, congratulations to Dr. Abhishek Pandey for organizing a thing like this. See, it is very interesting if you look at various discussions that are happening in the education front. It is all about new education policy, this, that, whatever. Very few people are looking at what is going to happen in the future. So I think, and Professor Nagarajan has already given you a fair amount of technicalities, I will try to put it into stories. So it is true that the difference is superposition, entanglement, and so on. And entanglement is so interesting that even Einstein did not believe in it while he was alive. He said there is something missing here. He attributed hidden variables, etc. But let me begin, and I will be more in a storytelling mode than in a professorial mode, because that you have seen a taste from Professor Nagarajan. It will take you a tough time to understand everything that is being said. So let's have a few stories. So first thing is, look at the news item. Last 2 days, what did we hear? The cabinet has approved the setting up of a public Wi-Fi network under PM Vani. What does it mean? It means that we want to provide internet access to a large number of people. 2 days before that, Mukesh Ambani said, we will bring 5G to India in the second half of 2021. The reason I'm saying this is that this push of technology, which is originally electrical engineering, then computer science, then AI, then this thing, is what is pushing us. And when we push it that much, there become limits to it. And therefore, the next thing that you want becomes a new technology. So let's imagine we have internet access to everybody. You will want it to be safe. You will want it to be secure. And therefore, it will have to be a quantum internet, because the traditional internet will not be safe enough, secure enough. So that's how this is a natural evolution. It looks like a story which has been created in that sense. I'd also like to introduce a phrase here called quantum supremacy. Now, quantum supremacy is a phrase which was first used by Professor John Preskill of Caltech. And Caltech is the same place where Richard Feynman used to be, and he first gave the idea of a quantum computer. But John Preskill said that quantum supremacy is that point at which a quantum computer can do some calculation which no classical computer can do in a reasonable time. And last year, Google, on I think 23rd October 2019, declared that their quantum chip called Sycamore is able to do something in 200 seconds, which the fastest supercomputer called Summit would have taken 10,000 years. And yesterday, or a couple of days before, China has said that they have also achieved quantum supremacy, and by a bigger margin, and so on. So I'm just trying to say that this is what is happening, and we are therefore in a stage of quantum supremacy. And now I want to share with you the story that typically when science progresses, it progresses out of just the curiosity of the people. They see things, they want to see common features in it, they want to unify things which are kept separate so far, and then it progresses. But then from the science, sometimes you get to the phenomena, sometimes you get to the technique, and sometimes you come to new technologies. We are at that stage. The technology is not fully developed and ready. But since we had a professor of electrical engineering, I want to begin with the story of Michael Faraday. So Michael Faraday once did a very simple experiment. He had a wire, he had a galvanometer, and he just waved a magnet around the wire, and electric current flew through that wire. If you look at it, it's a very simple thing. From his point of view, he was just showing that current, electricity, and magnetism are interconnected. And if there is a fluctuation in a magnetic field, it can induce an electric current. And therefore, that was called Faraday's laws of electromagnetic induction. A very nice story. So when he was making this demonstration at the Royal Society Hall, the British Chancellor of the Exchequer came and he said, "Well, Mr. Faraday, this is all fine, but what is the use of it?" And he says, "Sir, someday you will be able to put a tax on it. And as you know now, for electricity, we pay a certain tax on electricity." Now, this is the difference between it moving from science to technology. And you can now imagine you will similarly have got. Now, if you look at electrical thing itself, it started with this simple experiment, then Maxwell's equation, then something else. And the big thing that happened was the electric bulb which Edison had invented. That was the big thing in electrical. But that wasn't the only thing. After that, you had motors and generators and all machines driven by electricity, the microwave oven, this, that, completely this thing. And this is what I want to emphasize. It is not about quantum computers alone. It is going to be quantum technologies. So just like electricity is not about the light bulb alone, but about so many things which are all based on electricity, your elevator, your escalator, now your car, aeroplane, all these are coming out of that simple experiment which Michael Faraday did. So the simple quantum computers which are around and not very useful today will evolve in the next 5, 10, 15 years to this. And that is why governments are paying a lot of attention to it. And even private investors are also paying a lot of attention to it. Now, in terms of government, on the, I think, 7th October this year, 7th October, right in the middle of US election, Donald Trump approved a plan called the Quantum Frontiers Plan. And this is very important because I will take you to an older story. So anyway, so quantum mechanics, okay, one more interesting thing, that unlike many other phenomena where we can attribute it to a single person, so electromagnetic induction, I attribute it to Faraday, Maxwell's equation, Newton's law, and you can talk about so many things which you attribute to an individual. Quantum mechanics is not attributed to an individual. It is a set of 10, 12 people working over 10, 12 years in different parts or aspects of it. And then today, agreed common body of knowledge, which we call quantum mechanics. And they did not often agree with each other. Sometimes they did not agree with themselves also. So there's a very famous story that when Max Planck actually explained black body radiation, he said, "This is all right, but I am fitting to the curve. I don't know why," etc. So Einstein, as we said, did not believe in some of this part. So a lot of people had problems with it, but they were exploring and they found that this could explain a lot of things. One of the tangible things with that quantum mechanics resulted in is very interesting. So quantum mechanics for that many years, 20 years that it was being developed, it was all right. It was this half-mad scientist pursuit who were looking at things and imagining wave-particle duality, photon, quantum, this, that. They were appreciated on August 1945 when the atomic bomb was thrown on Hiroshima and Nagasaki. Then people understood the value of quantum mechanics. Otherwise, E equal to mc square was an equation which was meant for only theoretical people. But then they saw the energy released in that bomb was much more than any of the other bombs before. Alfred Nobel's gunpowder, this, that, TNT, there was no match. Then started technological races. Till then, science was pure curiosity. Technology was somebody like Edison who wanted to do something and make some money out of it, but there was no race. You will not hear any race in technology in that past. But nuclear weapon was the first one where there was a race because US then established itself as a superpower of the world based on knowledge, based on an equation like E is equal to mc square. So when you transform E is equal to mc square to technology, you can either get nuclear power generator or nuclear bombs. This was very interesting because at that time then US became supreme. And Russia, who was also a technological power, etc., was a little behind. And Americans for a long time thought that the Soviets come in and they spy on our things and they steal our secrets, and then they make the similar thing later on. So USSR, as it was then, was following US in making the atomic bomb, nuclear bomb, fusion bomb, and so on. But America got a shock on 4th of October 1957 when the Soviet Union put up the Sputnik. Now they realize, but they could not have stolen our secrets because we don't know how to do it. Then US went on a big mission for science improvement, completely changed. And when John Kennedy was elected in 1960, one of his first speeches was that within the time of 10 years, we will send an American to the moon and bring him back. And I think it was on 20th July 1969 that Neil Armstrong set foot on the moon, and the famous quotation that, one step for man, a giant step for mankind. This is where the technological races started. And then came the AI race. So artificial intelligence became a race. By the time of the race of artificial intelligence, there was another player who was competing in these Olympics, and that player was China. And in AI, China is neck to neck with US. The difference is that in the US, they have more research, more patents, more researchers. In China, they have more data, more applications, and so on. So many applications which are prohibited by law in the US, like face recognition for potential criminals and so on. In China, there is not so much respect for human rights, so they do that. But what has woken up, again, like in fact, Barack Obama called it the Sputnik Movement. Like the Sputnik Movement, US is feeling it may be left behind China in the quantum race as well. And that is why on the 8th October, they have had a massive program. So they are creating a program on quantum technologies. So like we had electrical, mechanical, civil engineering, you will have quantum engineering as a discipline. And as far as I know, it is only the University of New South Wales in Australia which already has an undergraduate degree program in quantum engineering. But US is preparing for it, and we should also prepare. To some extent, University of Roorkee has done it, that for its computer science students, it has put up a one-semester course on quantum computing in collaboration with Microsoft. So this is where it is going. Now, India is not really behind, because many of you will recall, or you can Google it, in this year's budget, February 2020, Nirmala Sitharaman allocated 8,000 crores for quantum technologies. And they had a whole plan about it, etc. It was almost like the plan in UK to have hubs where companies and universities will collaborate and so on and so forth. But because of the COVID thing and the budget crisis, I think not much has been done. But the fact of the matter is that we also realize that we have, and I have no hesitation in saying, we may not be ahead in the quantum computer development race, but we could be ahead in the quantum application race. So just like we did for IT, we are not great known for hardware or for patents in IT, but we are known for development. There is almost no place where Indians have not had a role in the major application. So similarly, for quantum application, it is possible that we can become fairly good leaders if we start early enough. What do I mean by that? Now, I've been part of the IIT system. I have a PhD from Roorkee, which is now an IIT. I taught for about 10 years at IIT Kanpur. I was a member of the board of management of IIT Delhi. And I want to therefore tell you now why IIT succeeded so widely. There was engineering education in India long before IITs were created. The Ginty College of Engineering is perhaps the oldest in India, perhaps the oldest outside Europe. Roorkee was very old, Banaras was pretty old, and all these colleges existed before the IITs came in the 1960s. But what the IITs did, they transformed the slide rule wielding engineer into a computer programmer, into a person who could solve problems by programming how to solve them. And what I'm saying is, the youth of India, which learns how to solve problems using quantum computing, will again be leaders of the world. And this is why it is very important. And it is why I'm talking about this awareness program for quantum readiness. Now, most of you know that in order to do something solve something on a computer, you need a hardware. In the IIT story, IIT Kanpur had a computer from USA, the IBM machine. IIT Delhi had an ICL machine from England. IIT Chennai had a Siemens machine from Germany. IIT Powai had a Russian machine. But the common thing was they were ready for the new paradigm of computers as problem solvers. And then when successive things happened, so when CAD/CAM came, they were ready with it. When 3D printing came, they were ready with it. So they were ready for all the consequences. Today, when we talk about computer technologies, ICT, we don't only talk about computers. If you say ICT, although computer is the middle name, what we are talking of is Internet of Things, we're talking of blockchain, we're talking of cybersecurity, we're talking of augmented reality, we're talking of virtual reality, and so on and so forth. Similarly, when we talk about quantum, Professor has already said, we talk about quantum sensors, we talk about quantum internet, we talk about quantum simulation, we talk about quantum in health and so on. So therefore, now the other point that I want to make is that this effect of quantum will be much wider than the effect of ordinary computers that we had. When computers came in India, and I'm among the early adopters, in 1967, I started using computers. And then, as I said, we had only a few computers and at PIFR. And many people thought that computers have nothing to do with people who are not engineers or scientists. It was only engineers, scientists, the space organization, and so on and so forth, who would use computers to solve the problem. Same thing with quantum. We are going to use this to do, as the professor said, variety of applications and many one in quantum biology. Now, it is, as I said quantum engineering will be a field, but there will be specialized field like protein engineering. The future of engineering is more around biology than around the traditional periodic table elements that we talk about as materials engineering. And this is why this is a hugely impactful thing. And because the learning time is a little high and steep, it is good to start on it as fast as we can. Now, let me take you to just the key things, because what is the key concepts? Let me spend a little time on doing that. So, as the professor has said, we are talking about, say, superposition, entanglement, wave particle duality, and so on. And let me spend some time on this to explain it. Now, actually, if you look at it, Newton talked about his laws of motion in 1686 or something, more than 300 years ago. In fact, the famous story is there that he saw that apple fall and he looked at the gravitational force. But what he wrote as the laws of motion are more universal laws. And interestingly, they were written in a book called Principia Mathematica, that is Principles of Mathematics for Natural Philosophy. And why it is Principia Mathematica? Because Newton's laws adopted and used calculus intrinsically. You cannot apply Newton's law if you really don't know calculus. And what are the laws? The laws are everybody continues in a state of rest or uniform motion in a straight line unless acted upon by an external force. And the second law is that the acceleration is proportional to the force. And if you know acceleration, it is d2x upon dt squared. So you are already talking about calculus to understand these things. And third is, of course, every action. But the point was, with these three laws, you could predict the motion of a particle if you knew the initial condition or at one point of time into the future. Even today, it is valid. It may be trivial, but it is valid and it works beautifully. The interesting and ironical part is Newton believed in the corpuscular theory of light. He believed light is a set of particles, and as you study in elementary physics or geometrical optics, incident ray, reflected ray, sometimes the refracted ray also if it is going through another medium. But he did not believe in the wave theory of light. Although Christian Huygens was talking about the wave theory of light, and Newton observed something which is called the Newton's rings, but he did not want to explain it as a wave. He would still say particles have very complex behavior and therefore they do it. But wave particle duality of light has been observed for 300 years. What happened a little later was that Father Thomson got the Nobel Prize for proving that electron is a particle. His son Thomson got a Nobel Prize for proving that the electron is a wave. And de Broglie got a Nobel Prize for saying that it is neither particle or wave, or both particle and wave. And he gave a formula which talked about the wavelength of a particle in relation to its momentum. This is why quantum mechanics is everywhere. And what is important and interesting is that when you look at Newton's laws, you have to assume it as God has given it. But if you take quantum principles, then you can derive Newton's law from that. And this is the kind of work which people like Feynman, etc. did. We talked about the paths that have been taken. There's something called principle of least action and a path integral approach to quantum mechanics. And therefore, it's a question of number of paths. So now what we are saying is, now if this is true, then everything at that level is a quantum phenomenon. And the level is when it is very small, and the precise definition for that is, in some sense, when what is called the action. So in physics, there you have various other things, mass, volume, speed, etc. There's something called action, whose unit is times second. So energy into time is action. More formally, you say Lagrangian over time, etc. But basically, when it is energy times time, it is action. And if that action is so small that is comparable to what is called Planck's quantum of action, then the whole quantum mechanics becomes manifest. Now, let me share with you. See, for us, it was very difficult when we were young to look at this because we did not have access even to microscopes, etc., etc. But for children today, and of course grown-ups as well, it is easy because you know all the things that you're seeing on your computer, all the pictures that you're seeing are made of pixels. And you also know when the resolution isn't right, we call it pixelation, because you start seeing the pixels rather than the whole picture. You are now looking at it like a quantum. So we are saying all these things consist of quantums of action, which is the pixel of energy times time. And when you are being able to look at that, you will be able to see the quantum phenomena. When you're not seeing that, there are so many megapixels in a small area, it looks like a continuum. And it looks like classical physics. Now, the point that I'm trying to say is, and I'm building on what the professor said in the introductory part, now, if there are waves, then waves can superpose and give a different thing. Particles don't superpose. Particles can collide or you can join them some way, but waves can superpose. Take a musical performance, for example. In a musical performance, the waves coming from various instruments, and also maybe the artist if he's singing a song, and you hear all these waves together because they have superposed to give you the music. Quantum computing and quantum phenomena is about superposing these waves. So just like if these sound waves are in coherence, they are in phase, then it is music. When they're out of phase, it is noise. Same thing will happen in quantum technology. Quantum technology, the role will be to deal with the amplitude and phases of these things and have them in coherence, and then have, like we said, music is achieved, their huge computational power is achieved, or a huge sensitive power is achieved, or whatever. So this is why it is very, very interesting that we are just trying to say, now, what is the job of a music synthesizer, etc., to pick up these various things, mix them, and what do remixers do? They mix it in a certain way but they do only waves. Now we are talking of something which is both a particle and a wave, and therefore is written by whatever is called a wave function. And all quantum technology is about dealing with their amplitudes, their phases, making them coherent, and because it is so difficult to do, it becomes decoherent very soon. And therefore, quantum computers can work for a very short time today till these phases are in alignment, because any kind of disturbance can disturb this and cause decoherence, and we're able to do that. So I try to kind of give you metaphors and analogies to explain what this is like. I think I shouldn't be too long because then it will become. But so the next thing is how to be quantum ready. Answer is very simple: self-learning. You cannot wait till some approved body gives you a course in quantum engineering or quantum physics or whatever. A lot of information are available on the internet. So, including on Facebook. On Facebook, there are groups which deal with quantum. So, it is important to take an interest, to keep your thing, and you will have to be reasonably okay in physics and maths if you want to go to the next step. And in that, basically, we're talking of linear algebra is one of the common mathematical forms. Just like in simple school level arithmetic, geometry, you learn various quadratic equations, this, that. You learn linear algebra in a certain way. It applies to AI also. Most of machine learning is linear algebra. If you look at whatever we're using for machine learning is also being used for quantum computing. Machine learning, we use linear algebra, matrices, statistics, Bayes and probability things, and so on. Quantum mechanics is also largely statistical, this, that, vector spaces, different kind of things, and so on. So that is the kind of thing. The good thing is that that is required for the understanding. But once the computer system is available, you need to know programming languages. So Microsoft has a language called Q#. Somebody else has something else. So you need languages, you need algorithms, you need this thing. So it's a simple extension of the way we did computer programming. Just like when we do ordinary computer programming, we don't know what is going on inside the chips over there and those millions and billions of transistors. We are talking of using it as a software. That's the same thing with it. The big advantage in learning quantum today is that unlike the story that I told you of classical computing, where you had to have that computer with you, and whatever computer you had, you were limited to that. So if you had an IBM, you had an IBM operating system. If you had digital, you had a VAX operating system. ICL had some other operating system. Today, all quantum computers are being offered on the cloud. So you don't have to buy anything. So whether it is an IBM or a D-Wave or a Google or a Microsoft, you can play around it with on the cloud itself. So you just need good internet infrastructure and the desire to learn. And what I suggest, create a community of learners. To create a community of people who say, we are quantum computing explorer or quantum technology explorer. They can begin with this thing, and then you can always look toward, like Professor was there, for guidance, etc., who can tell you what is the big picture, how you go about doing it. So my own belief is that the motivated people, the people who are hungry to do well and want to make lots of money, because today the highest money is being paid to quantum computer programmers and quantum technology developers all over the world. So US wants you, Canada wants you, Australia wants you, England wants you, even China wants you if you want to go there. So that is the kind of a thing. So I hope this has been of some interest. I'd like to stop now because I don't want to go too long. I know that sometimes professors can get very boring. They keep on, and therefore this is a good time to stop. You already have a professor amongst you who can lead you. And of course, I am very happy to share more information, more ideas, more concrete things with you as you want. So all the best and thank you. And I hope this turns out to be a very interesting seminar for all of you. Over to you, to the organization.
Thank you, Professor. You have given a lot of information and insight about quantum technology. Especially, as an electrical professor, I'm happy to hear from you about Faraday's law and how you have connected Faraday's and Maxwell's equations to emerging technologies like artificial intelligence, cloud computing. Especially, you highlighted how cloud computing. I'm really impressed about your presidential address. I hope this is going to be a fruitful discussion for the wonderful evening. With that, I'm happy to invite the next speaker, our guest of honor, Engineer Potsufaro Sergi, Quantum Tech, Russia. Sir, over to you.
You are muted, sir. Kindly unmute. Professor Ragarajan, he is muted.
Yes. Even that mic symbol is not showing.
Yeah, I can see the mic symbol. It's muted.
Professor, can you unmute? Can you able to hear me?
Or as a host, you can unmute him.
Yeah, as a host, unmute it.
I am not. For me, it is not showing. Mic is not showing. I am not able to do that. Yeah, let me try. Yeah.
Co-host, Dr. Shruti, if she can see that one.
Oh, here, yeah, unmuted.
Yeah, now done.
I'll just do that.
Продукты питания, поступающие в последние годы в сетевые магазины, тоже не отличаются экологической чистотой и негативно влияют на здоровье и продолжительность жизни населения. В 2009 году было создано устройство активации воды. Меня слышно? Алло.
Sarji, Parchov, can you hear me?
Я выключил звук, как вы попросили.
Actually, we are not very much comfortable in Russian language, so you have to carry on. Since you are not very good in English, so you can carry on your speech in Russian language. We'll be listening it later on while using the translator.
I think Professor wanted to share his screen, it seems. Have given his co-host privilege.
Thank you. Just let him share the screen. Actually, he wants a screen share. Yes.
I am ready.
Yeah, Professor, you can share your screen and proceed.
Я продолжу. В 2009 году было создано устройство активации воды. В 2009 году было создано устройство активации воды. Вода после активации стала создавать вокруг себя поле и передавать свои свойства обычной воде. Данную воду мы начали называть БАФ, биологически активная вода. Она стала повышать иммунитет животных и людей, увеличивать урожаи злаковых на 25-70%, на овощах до 400%. При этом содержание нитратов после применения этой воды снижалось в 2-3 раза на открытом грунте и в 19 раз в теплицах. Фактически полученная биологически активная вода – это эффективный стимулятор роста растений пролонгированного действия, действующий в ряде случаев до конца вегетации. Основная цель на этот период – создать продукт, гарантирующий стабильность повышения урожаев разных культур. Полученная вода оказалась, к сожалению, нестабильной и в ряде случаев переставала давать прирост урожая. Причина – любое энергетическое воздействие на БАФ – это солнце, СВЧ, электрические поля и так далее – снижали ее эффективность. В течение 11-13 годов нами была проведена работа по созданию эффективной цифровой копии спектра излучения биологически активной воды, на которую не влияли бы вышеуказанные поля. Финансирование данного проекта осуществлялось семьей, друзьями и знакомыми. В эти же годы стал вопрос передачи биологически активной воды в другие страны, без потери ее эффективности. Передача БАВ в другие страны с возможной потерей ее эффективности разрушала проект. Простая передача цифровой копии спектра излучения БАВ превращала данный проект в некоммерческий. В 2013 году меня пригласили на семинар в фонд Сколково. Рядом со мной сидел человек, который рассказал мне, что его компания занимается передачей информации на расстоянии. В какой-то момент его рассказа я понял, что я сам могу пересылать спектр излучения БАВ в любую страну на любом расстоянии. А далее была реализация идеи, и начались тесты передачи этой воды на разные расстояния в разные страны. С этого момента началась квантовая составляющая проекта. Передача спектра излучения БАВ в другие страны через единое квантовое состояние разделенных фотонов. Металлическая емкость из Ханоя, Вьетнам, и ее фото в Москве условно можно было считать разделенными фотонами. В Москве я начал воздействовать спектром излучения биологически активной воды на присланное из Вьетнама фото. Предварительно я усилил поле излучения БАВ в резонаторе. В это время в Ханое в экспериментальную емкость была налита обычная вода. Через 48 часов из емкости во Вьетнаме начали тестировать на рисе эту воду по стандартному тесту на энергию прорастания и всхожесть семян. Контрольный рис замачивали в обычной воде, а опытный рис замачивали в воде из емкости. Тест дал явный положительный результат. На 20% увеличилась всхожесть семян, и в несколько раз контрольным увеличилась длина проростков опытного риса, то есть ускорилось деление клеток опытного риса. Далее было замечено, что воду можно заменить растворимыми кристаллами. В дальнейшем вьетнамцы остановились на сахаре, как на самом эффективном носителе информации. Подобные тесты были также проведены в Индии, в штате Хайдарабад, в Судане, Хартум, в Иране, в США, в Калифорнии, в Египте, на Украине, Молдавии, Мьянме и в других странах. БАВ, полученный в этих странах, ускорял обменные процессы растений, увеличивал плодообразование, повышал урожаи и на 15-20% сокращал период вегетации. В процессе проведения тестов БАВа фермеры обратили внимание, что после опрыскивания растений программой БАВ пестицидами, программа БАВ у растений стиралась, и рост этих растений значительно замедлялся. Как временный выход из этого положения решили повторно растения опрыскивать раствором БАВ. Проблема была решена, но произошло удорожание работ. Перед нами стал вопрос создания информационных инсектицидов. Так как другие виды пестицидов значительно меньше влияли на растения, в течение года мы получили цифровую копию инсектицида широкого спектра действия, который значительно снизил зависимость фермеров от химических инсектицидов. В середине августа 2019 года мой партнер из Индии предложил не активировать воду в емкости в Индии, а воздействовать из Москвы напрямую на растения в поле спектром излучения БАВ через фотографию этого поля. воздействие осуществлял на поле с проростками дыни площадью 8 акров, 2,5 гектара, в районе Хайдарабада. Через месяц дыни на опытном поле зацвели, а контрольное поле отставало от развития на 12-14 дней. Количество завязей дынь на опытном поле увеличилось на 70-80% контрольному. В начале ноября дыни собрали с обеих полей. Прирост урожая на опытном поле составил 82%. Условия реализации проекта. Исполнение распоряжений разработчика, обучение партнеров и фермеров порядку применения полученных продуктов, своевременное информирование разработчика состоянием растений в случае заболевания растений и появления на полях насекомых-вредителей. Преимущество проекта. Данный проект превышает рентабельность сельского хозяйства. В 2012 году в Молдавии БАФ применили при выращивании товарного подсолнечника на площади 100 гектаров. Для этого использовали 10 грамм БАФ для предпосевной обработки семян. При уборке урожая, прирост урожая опытного подсолнечника на этой площади составил более 50%. В денежном выражении это около 30 тысяч долларов. То есть 10 грамм БАФ дали доход более 30 тысяч долларов. Данный проект повышает экологическую чистоту и улучшает вкусовые качества плодов в растениеводстве. Возможно значительное повышение урожая на площадях в сотни тысяч и, возможно, миллионы гектаров. За счет ускорения обменных процессов в растениях от применения БАФ обычные культурные растения на засоленных почвах превращаются в галофиты, то есть обеспечивают рассоление брошенных почв. Благодарю за внимание. И по скрипту. Аналогичные технологии используются мною при создании в других странах эффективного иммуномодулятора с помощью переноса спектра излучения одной из разновидностей активной воды на обычную воду, без изменения в ней физико-химических свойств. Аналогичные технологии используются мной также при создании в других странах катализатора топлива. Это дистанционного. Это устройство располагает в салоне автомобиля, который создает поле и повышает теплотворную способность топлива, обеспечивая его экономию от 15 до 25%. Thank you very much.
Thank you, Professor, for accepting our invitation and grace the session with your speech. Spicy go. Thank you.
Thank you. Thank you.
Next, we'll move on to the panel discussion. We have 5 eminent speakers today's session. Let me welcome first Professor Varkamal, King's Monkscoats University of Technology, North Bangkok, to open the discussion. Due to want of time, I request all the panelists to restrict your discussion within 10 minutes. Thank you.
Okay.
Ma'am, over to you.
Okay, thank you. It's my turn. Probably I need to share my screen first. Just a moment, please. I need to share my screen.
No problem, no problem. Take your time, ma'am.
Okay, good evening, everybody. Probably I'm not good in quantum technology in Thailand. Quantum technology is quite new in Thailand. Probably we just like the stars. Around our community in Thailand is just be 50 people, but we hope to 100 people in the future for scientists, for engineering, and for academics in related field of engineer and physics. We use like community to build the new science for quantum technology in Thailand, but probably we don't have a lot of invest money or the big money from government yet, but we hope so in 5 or 10 years. Okay, actually, my university is like King University of Technology, North Bangkok in Thailand. Our university, my university is invent a lot of science and engineering. That's why quantum technology is quite very important for our students because nowadays we put for 21st century students to learn creativity, not only lecture room. So properly, as many professors says before about quantum technology is like physics and engineering combined together. And as you know, quantum technology is the one more confound areas of physics, exploring the behavior of the subatomic, subatomic particle and has the potential to overturn the fundamental laws exhibited by Newton and Einstein. As you know, is the beginning of the quantum technology, right? The amazing thing about the computing is that can solve the problem by way you use quantum technology in every day. As you know, in computer, LED, photo detector, other quantum technology, GPS sensor, transmitter. This one is the first era for the quantum technology in everyday, as we usually use. And professor tell us about the GPS or exactly, but for the if we use quantum technology in 5 or in 10 years, we have the exactly GPS, just exactly not calibration or something like that, not mistakes. And quantum information and quantum technology are not the forefronts of the second quantum revolutions. Quantum enhanced applications will drive the technology progress in the 21st century and will play a similar role to that of electromagnetism and digital revolution in the last century. And this one, the from 2015 go to 2035, we nowadays everyone want to optimize for the result of quantum technology, but we're not in the end of the stage. As you know, for the regions of quantum technology, but what we learn and we apply for quantum technology nowadays. Quantum technology is this one is the second era of quantum technology. It's like automatic quantum clocks, automatic sensor, intercity, quantum links, quantum simulator, quantum in the internet, and universal quantum computer. And this one gonna be put day by day. I think maybe not 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 maybe we can use the updates for help for the public for everything. So as the computer integrate together properly, we use only one computer to analyze or communicate together. But in 2035, maybe we can use a lot of too many computer, maybe in the eight computer in the one time or something like that for universal quantum computer. And this one, copy what my next slide. Okay, this one, the funding for quantum technology source for the economics from 11 March 2016. This one all around the world, they invest a lot of for the quantum technology, but I can show you it's not including Thailand because we underdeveloping country, so we don't have a lot of money, and I will tell you later why we not invest for quantum technology in Thailand. But this graph is show you about the European. You see the budget around the world is $1,500 million for invest about the quantum technology. So that's why it's very, very important for the Europe, Canada, US, and can you see the Asia is like the biggest foundation in China, right? Now, although quantum computer have not yet been applied to various industry, but many countries are accelerating the development and research of this technology to base of its ability, not only Europe and America, but there are also many countries in Asia that have invested in quantum technology such as China, which has invested in developing the world's highest quantum technology worth over $100 million. And also this one, I would like to show you a little bit about the computer. So for easy understanding about the bit and qubits. Probably now 2020 about the bits. As you know in computer, no, only 0 and 1 have only 0 and 1, only 2 digits. The state can be 0 or 1. But if we simulate or apply the quantum technology for the qubit, every point of the shape is vary the state. Coin properly is like the toe or this one, only two sides. But for the qubit, every point is like the symmetric, is the depth or the height, is like use the physics and engineering combined. That's why it's like very genetic, and it's like qubits can calculate more accurate in valid state. This one is useful for quantum technology. And also, I will show you a little bit about sample already. And this one, Thailand plan to develop innovation, new technology have long been chosen in secrecy, but now they form part of nation strategy as Thailand Nation Plan 20 year for Industry 4.0. So actually easily to tell you guys in Thailand now we just like the 0 or 0.5 for quantum technology is quite new, but we have association to do, and I will show you. For science, hope to develop highly exact sensor outer secure communication and supervised computer using the technology. And Thailand, we have quantum technology development plan to the goal of developing both two, and researchers is less than 10 years. We may see more tangible quantum artifacts such as atomics, high precision, cost-effective random numbering. Still don't know what Thailand want from quantum technology. To be honest, Thai quantum scholarship students as are talents as any other nations, and only after graduating and returning to Thailand, there are not yet enough projects or entities supporting quantum development. Therefore, having to help with quantum works abroad. This will therefore prevent to the future for our new generation of developers. And also, for the next slide, the concept still don't know what Thailand want from quantum technology seriously, but we just start up the new just newborn. If like for Thailand, there are around 50 Thai scholars who are studying in graduate from world-class university. These 50 people will play a key role in making Thailand a competitive country for quantum technology if there is a continuous support from the government and the private sector. A world-class Thai quantum startup might not be too far for racing. This is from Medium 2019. And at the end, for the last, for my points, Thailand and quantum community, Thailand, we have single atom tapping system at Chiang Mai University in collaboration with the Thailand Center of Excellence in Physics. They will release their picture of taps single atom soon. There are quantum labs being set up at Suratnagari University of Technology and Mahidol University, Prince of Songkla University, Kasetsart University, Chulalongkorn University, and King Mongkut University of Technology, Thonburi, and also National Institute of Meteorology, as well as a new startup, quantum technology endeavor we can call Q, to help promote quantum technology to the public. This one, the gimmick of the Q, quantum technology endeavor of Thailand. That's all for my point. Thank you so much for listening, and okay, thank you. Thank you very much, and sorry for my accent or something like that. Thank you.
Thank you, Dr. Ora Kamal. Next, I would like to welcome Mrs. Angelina Marcus, Langa Pacific Aviation Academy. Ma'am, over to you. Mrs. Angelina Marcus.
Professor, please call another
Yeah.
panelist.
Yes. Now I would like to welcome Professor Mutmaina, Al Aishwarya Mandir University, Indonesia. Ma'am, over to you.
Thank you. Thank you very much. Allow me to share my screen.
Yeah, just a minute.
Well, before I start, I want to say good evening from Indonesia. Thanks to my brother, Dr. Abhishek Pandey, for the great invitation for having me tonight. And also to all of the keynote speakers for the wonderful presentation. And also thank you to the organizing committee, and Charles Walter Society, Innovation and Research, family and team. So yeah.
Now you can share.
Let me share my screen. Thank you. You can see my screen?
Yes, no.
Okay. This is a little bit about my profile. My name is Mutmainah, but you can call me Nina for the simple name. I am lecturer in the Faculty of Teacher Training and Education, Al Aishwarya Mandar University in West Sulawesi. And this is some of my organization, national and international organization. And also I am a member of Charles Walter Society, Innovation and Research. Well, our topic today about the quantum technology, and then let me share about the quantum technology in my area in education. So you can see here, this is the phenomenon right now, the challenge and the issue about the quantum. In education sector, we have actually namely quantum learning, quantum teaching, quantum technology. And also my perception about a quantum technology in education. This is about the use of unlimited technology and how to integrate technology in our learning and teaching process. Well, and I believe in this forum, our audience, most of all, or maybe all of us, we are educator, we are a teacher, we are a lecturer in university or in the school. So I divided some of the highlight about the quantum technology concept in education sector. I divided into 5 here about how to inject artificial intelligence in education. And right now we are our education sector, we are transformation, we are practice and use namely remote teaching, virtual classroom, distance education, and we must adapt with the information, communication, and technology culture. And we are need to design our a new curriculum based on the condition. Yeah, for right now we are still already during the COVID-19. We are practicing physical distancing, social distancing, and we are lost our physical classroom. And then about the infused smart digital classroom management in the education sector, I introduced to you about the quantum learning, quantum teaching, and now we are in the quantum technology. And I believe right now we are massive use technology in our learning and teaching process because we are in the physical distancing. And also cybergogy in the education sector. This is one of the theory that I use when you are integrated technology in your learning and teaching process, and you are combined between technology and then pedagogy. This is namely a cybergogy. And in the cybergogy need to improve the student metacognitive skill, knowing how to learn. And then in Indonesia, how to solve the problem during the COVID-19 in education sector by using some of the technology platform or application. Our ministry a policy about freedom to learn. And also we need to infuse for our society, our student, our teacher or lecturer right now, the digital vaccine. Right now we are in the society 5.0. And all our activity delivering by using the internet, or we are now the internet of things. And then industrial revolution in education, this is how to combine between education and in industry. And then we must facilitate our students with the 21st century skill, communication, collaboration, critical thinking, and creative. And the last one about the pedagogy evolution right now. In the pedagogy, as you know that in education, this is not only about how to transfer knowledge, but this is about how we are teach our students how to treat them, not only about how to develop in their character, they believe the value, and also about behavior and attitude. And then in the pedagogy right now, how to integrate the technology in our learning and teaching process, and use some of the some of the quantum technology. Mean here use unlimited technology in our learning and teaching process. And my title today, or my topic today, about the cybergogy for the next future education. And also I divided our highlight issue today. I want to share to you, and we are discuss about the quantum technology on education sector, the cybergogy, and the concept of Merdeka Belajar or freedom to learn in Indonesia. Well, this is about the quantum technology on education sector. We must now, right now we are in the digital era, and then we must facilitate our teacher to becoming a digital teacher, our student or learner to becoming digital learner or digital student. And then we are now how to train our teacher, how to use, how to teach by using the technology. As you know that based on the data from the British Council, maybe this is not only in Indonesia, some of the country happening the problem and challenge when they are remote their learning and teaching process by using the technology. Most of the teacher, most of our teacher, they are low skill how to integrate with the technology, use some of the application, or they are low in computer skill or competence. And our challenge today, this is not about only about the student, this is about the teacher. You know that today most of our students, they are actually they are more have skill to integrate technology by using, for example, the smartphone. So also we must prepare the teacher right now. You know that our student not like us, your students are not like you, accept it and teach differently. How to teach them differently? You know our student characteristic, their learning style, they are Generation Z, and then they are familiar by using the technology or the quantum technology right now in education sector. And this is about the how to mobilize our student right now. You must identify your student learning style, what their learning need, and the technology that we can be used today. Because right now, everything delivered by the internet most faster. And then we need the student, prepare our student with the self-direct and self-determined in the learning process. And you know, we need to prepare them with their information or ICT skill, and then they are more interactive in the social media. And also, this is one of the example from education in the Scotland. Scotland, they are actually apply or implementation about the quantum technology. Most of facilitate with the digital, and then in my country, we are still on the process to becoming a digital in everything. You know that Indonesia, we are most of Indonesia area, we are in the developing country, and 50% of Indonesia area, we are in the blank spot. Blank spot, namely, they don't have internet connection. So how to solve this problem? In the another side, we must use the technology, but in another side, we are still need supporting from the government how right now facilitate all of the area in our country by the ICT infrastructure. And you see now, this is the future of education will be everything handled by technology in the cloud. And the cybergogy, this is the concept when you are namely combined between technology and pedagogy. Pedagogy, this is the methodology of the way you are teaching or the approach you are teaching. I mean here, today we are not talking about the not only about the technology, but how we are have a design our syllabus, our lesson plan, our activity until our assignment integrated with the right technology, the right application, or the right platform. Well, this is the cybergogy for engaged learning, increasing the level of present by Wang and Kang theory. This is divided into three factors here about the cognitive or the theory of behaviorism in education, a sector, the social constructivism and emotion. We must engage our student in learning environment, how to cover all of them, cover their cognitive, cover their social community, and then cover about their emotion. Are they feeling enjoyable when you are teaching by using some of the platform, for example? And then in the social community or social constructivism, we need to building our student community, even we are now in the virtual classroom. For example, in my class, my student familiar by using WhatsApp, so we are our community in our virtual community discussion by using WhatsApp or using Facebook or another social media. And then you can evaluate giving a reflection with your learning and teaching process. You can ask, what about your student? Are they feeling enjoyable when you are use some of the technology? Maybe another university, they are comfortable by using Microsoft or something by using Skype, for example. But maybe this is different with your student condition. Your student, what is your student actually familiar with the technology? And you can use the technology, the familiar technology with your student. Yeah, example, my student, they are familiar by using WhatsApp and the Google Classroom. I use them to in my classroom. Yeah, this is the intersection between pedagogy and the technology. This is about the infrastructure. Yeah, we need now how to facilitate everything in the classroom, public service with the infrastructure, the ICT infrastructure. And this is about the technology interaction in the classroom. This is in education. You must prepare your instructional goal, design thinking standard. This is for the student, and developing the technology skill for the teacher. You know that most of the teachers, they are still have a low skill by using some of the digital technology, and we need to share and train them how to use the right technology to achieve namely the Bloom taxonomy in education. or to achieve normally the higher of thinking skill. So, well, this is the concept of the triple quantum learning, quantum teaching, and the quantum technology in the education sector. The theory, the cybergogy, this is a need to be how the learner thinking, behavior, emotion, are deeply connected to the culture right now about by using computer or the internet. We must adapt and we must train our student or our learner right now. And then mobile gogi, we need to train them what is the right technology, the right application to achieve namely the Bloom taxonomy or the higher of thinking skill. And the last one about the digital pedagogy. This is the digital pedagogy. You can use the contemporary digital technology in your learning and teaching process, or use unlimited technology based on your student and your condition. And this is freedom to learn. This is from our ministry in in Indonesia, our Ministry Education and Culture. They have a policy about a freedom to learn. And this is the concept of the freedom to learn, how right now we are redesign our curriculum, and then we need to improve the student learning quality, independent, and autonomy in teaching. And then about the freedom to learn, actually this is mostly asked to facilitate and use the student-centered learning approach. And well, this is the learning paradigm. You know that we are in the pedagogy evolution, and this is, yeah, maybe we need to change our learning and teaching style right now. You see here about the how the knowledge right now change in when we are in learning and teaching process. For example, in the first one, this is pedagogy evolution one. This is knowledge we can adapt the knowledge, and then knowledge we are product, and the last one knowledge this is just for navigation knowledge. And well, how to use the technology get there in learning and teaching. The teacher right now able to support a student deep learning, represent ideas in powerful ways, organize productive learning process, and evaluate themselves the impact of their teaching. And then the teacher right now need to be developed or upgrade their competence. They must know or identify their student learning style or the student condition, and then redesign the curriculum based on the student, what they want, what they need. And then we need to be right now the teacher to integrate some of the technology in the classroom. And also this is the concept of learning autonomy induction to supporting namely freedom to learn. This is about how right now we are change our student mindset or the ways of thinking right now. In learner, our student, we need to improve them, their facilitate them with the social skill, the thinking skill, how to management skill, information skill. This is referred to the metacognitive skill. And then the ways of thinking right now, how our student can create, to be more create or achieve namely the Bloom taxonomy, the higher of thinking skill, and then use some of the resources to accelerate their learning process. And well, this is the stake of personalized in learning environment. Maybe most of us still have a look about when you are teaching. This is about what is the teacher want. And right now, maybe you can change this concept. You must collaborate with your student, analyze what they want, and then you can together collaborate to redesign your learning environment based on your student condition, your student need. And while this is about the some of the technology, this is the pedagogy world today. I want to show to you this is the right technology based on the Bloom taxonomy. This is, for example, remember, understanding, apply, analyze, evaluate, and create. This is the right technology that you can be used when you want to ask your student to remember or understand. This is in still low thinking skill. And then what is the action? The action you can ask your student to, for example, this is the action verb, and this is the activity that they can be used when you wanted to achieve a namely remember and understand based on the Bloom taxonomy. In apply, analyze, apply, this is the right technology, the right action, the right activity. In analyze, in evaluate, and in create. And then how to connect this with the quantum technology right now in education sector. We need to facilitate our student, our teacher with the unlimited technology. Unlimited technology you see here based on the pedagogy well, the right technology for the right skill or the competence. And also this is some of the core teacher application or the core of student application. When you explore this, is most of them use namely the social media. We are use social media in our classroom. And also about the independent or the freedom to learn. And actually we need to train our student or maybe our teacher. There are many resources, there are many platforms that we can be used to upgrade our knowledge. For example, in Indonesia, our ministry available about the SPADA. This is the LMS. And then this is, for example, by using Coursera, FutureLearn, or EdWeb webinar, and also a cyber education webinar. And then this is the example of artificial intelligence platform. This is the application. For example, this is EVBoot, Misuku, or Replica, because I am teaching English. So we can use the artificial intelligence frame to improve the student speaking or communication skill. And let me show you about right now about how to use the technology in learning and teaching process. This is one of the model of instructional design, namely ASSURE. ASSURE, this is the acronym from analyze, state objective, select method, media and material, utilize media and material, require learner participation, and the last one, in the end of the semester, you can evaluate and revise. And this is the very important here before the semester start. We need to know, analyze our learner, who is our audience, what about their competence, what about the learning style. For example, in my classroom, in my unit, in my classroom, most of my students, they are learning style, they are in the visual. So I ask them what they want. They like their learning by using a video. So we facilitate them with by using a video in learning and teaching process. And the next about the study objective, this is about how to the learning outcome, about to improve what is actually the student, namely here the competence. And the third, you can select the method, the media, and the material based on the student condition, and you can product the new material. And then when in learning and teaching process, you can utilize the media or your media or material. You can experiment them in the classroom. And also you can ask your student to participate with the discussion and small group activities, and then give them formative assessment. And the last, you can evaluate your learning and teaching process. You can ask your student, what about your learning and teaching process? And this is the example I want to share to you about how to design in the interactional design here. I divide it into 5. This is the example here. Taxonomy based on the Bloom taxonomy. For example, we even adapt this based on the subject. For example, in the warm-up here, you can ask your student to remember the film or the movie. And then after that, this is, you can, in the presenting, you can ask your student to create a namely brainstorm. Analyze based on the Bloom taxonomy. And the next about the practice. In the practice, you can ask your students to discuss the film. And also in the production, you can ask your student to write a composition based on this, the film they have watched it. And then after that, they can create a simple movie or a video or project. And the last one, in evaluation, you can ask your student to answer this question based on your materials or your concept. This is in evaluation. Taxonomy. Oh my God. Hello? Wait.
Yes, ma'am. Yes, ma'am.
Madam,
wait,
you are audible. You are audible, but you are playing the video while conversation. You are playing the video.
Wait. Oh, I have problem with. Okay. Yeah. This is the example, and this is for the conclusion of my speech today about the technology in learning and teaching process. We can use technology to make our learning and teaching to be more practical, efficient, and effective. And this is the example of my classroom when used technology by using the smartphone and digital material in the classroom, and also during the COVID-19. And what about if the student, they don't have, namely here, internet connection? You can see here, this is one of the solution. They are use namely TGT teams against tournament. This is the during COVID-19. Most of the students, they don't have internet connection and device. Yeah.
Yes, ma'am.
This
The
is
question
all I
raised
have
is right
today.
because
Thank
every
you.
child
Yeah.
in
Thank you.
India does not have
Yeah.
the internet connection. In
Yeah.
the interiors, how does the education go?
Yeah. This is one of the solution that you can be used when the student, they don't have internet connection. You can use, I give you the example by using TGT, cooperative learning by Robert Slapping theory, TGT. This is a team against a tournament. You can ask your student to play, and they are feeling enjoyable and feeling motivation. And also, yeah, this is actually you can adapt in India when the student they don't have internet connection. I mean that here nothing can stop education. Internet or without internet, this is based on the how the teacher or educator must be creative to solve the problem, and then use the right method, the right application, the right media, or the right technology based on the student condition. I have give you the example in the when we are during the COVID-19 in the first semester, when we are under attack, firstly COVID-19 coming to Indonesia. I use many platform. For example, I use Zoom. Like today, I use Google Meet. many platform I experiment to my students. They are not comfortable. They are very confused. And then I change my teaching style. I ask them what is actually familiar technology, the familiar technology based on your condition. You know, most of the students, because during the COVID-19, our economy down. Our economy down. Most of because when we are use technology or the platform like today, we are using Zoom. This is high bandwidth and rest most quota or money. Money. When we are talking about technology, this is money. Rest money, money, and money. So what about our condition, student condition? They don't have much money, for example. So I change my teaching style. I ask them what they want. Yeah, they are only familiar by using WhatsApp, by using SMS, or by using Google Classroom. Why? We use them. We use them. Another school, they don't have internet connection, so we are used. For example, I showed to you TGT, team games, a tournament, or cooperative learning. This is actually today. This is not about the technology. This is about the pedagogy, the methods, how you are designing your syllabus, your lesson plan, your activity, your classroom, you manage your classroom into the assessment. I think this is all I have answered to you. Thank you for having me.
Thank you, Mothamina. Thank you very much for being connected. Over to Professor Nagarajan to call another panelist.
Thank you so much, madam. Actually, before pandemic, we never ever allow our students to use mobile phone in the campus. Now, it is the time to encourage our students to use the technology so that we can able to continue our education without any break. Thank you so much, ma'am. You have given a lot of insight about how technology can be utilized for education, especially during this pandemic period. Now, I would like to welcome the next speaker, Mrs. Angelina Margus, Langa Pacific Aviation Academy. Ma'am, over to you.
Greetings. Hello, everyone. Can you hear me?
Yes, ma'am. Yes,
you're audible, madam.
Am I audible?
Perfectly,
Yes.
perfectly audible.
Greetings. Yeah, and first of all, I would like to thank you, Dr. Abhishek, and the whole team, Dr. Nagarajan, to inviting me for this panel. And it's a great privilege. And I have learned a lot about this discussion on quantum technologies. And little bit about me and our company. We are into aviation. I'm into aircraft maintenance engineering program. We are teaching young children who are the school leavers and also technicians, engineers.
Sorry, madam, I have to interrupt
become
you over here.
international license holders.
Can you please switch on your video? Switch on your video. Because the visual is not there.
Okay,
Thank you, madam.
Oh, give me 1 minute. I'll switch on my video. Give me 1 minute. Give me a minute. With some friends, so I wanted to come out from that place. Give me 1 minute. It's okay. I'm with my some of friends, and I'll come back to you. Give me 1 minute. Can I close the door, please? So I'm going to switch on the video. You all please go out. You can listen, but you know. Okay. My video is having a problem. Give me 1 minute, I'll sort it out. I think I have not on the camera for Zoom.
Madam, if it is complicated, please carry on without your, video. Please carry on. If it is very complicated, if it takes a lot of time, then kindly continue. Continue with your talk.
Madam Marcus.
Dr. Abhishek, this is Baljeet here. Am I audible?
Yeah.
Yeah.
I think ma'am is not there in the list, participant list. Madam Marcus, are you there?
Kindly conclude the program if she is not there, because it's already late.
She left the session. Can we check it again? I think some technical issue.
She is joining right now.
Yeah.
Connect your audio, madam.
Right, connected. Can you hear me?
Yes, ma'am. Yes, ma'am. You can proceed.
Oh, okay. So just to give a few introduction about I'm very new to this quantum technology, whereas I don't have much information about that. We are into aviation. We are training engineers, technicians, and mechanics to work in the aircraft. Whereas I have come to know is now Airbus has introduced quantum technology. They are in a big way doing their researchers to implement this technology in using components, especially in avionic sections, and then communication and aerodynamic. This is it's very, very initial stage. So for me, I'm very new to this area, since we are into this engineering in aviation. And I learned a lot about this during this meeting. And can you hear me again?
Yes, ma'am.
Hello?
Yes, ma'am. Yes, ma'am. You can continue.
Hello? And sorry, I was in a middle of a discussion. There is some disturbance coming in. Sorry. Okay. Now, how this Airbus thinks is quantum technologies they expect to create a massive paradigmic shift in the way aircraft are built and flown. Airbus, they think that can be an early adapter of quantum technologies to enhance the performance of their products and service and help them to solve the most complex aerospace challenges. This is what they think. It is like they're exploring of number of quantum technology that can be applied into aerospace challenges. These technologies include sometimes quantum computing, quantum communication, and quantum sensing. So it means that the quantum sensors are effective, they said, measuring physical qualities such as frequency, acceleration, rotation rates, electric magnetic fields, and temperature with the highest relative and absolute accuracy. This is, and they believe that this could have direct application in improving their navigation system, in which precise acceleration measurements is used to achieve positions data. In addition, what they think is, what they analyze, quantum sensors could act payloads for range of different applications, such as climate dynamic and satellite or underground resources surveying from an aircraft. And also, the company, this is the only company at this moment in the aviation, they are analyzing how to apply quantum technology in their products and services. Then it is in also industry, that industry has complex computational needs in the area of fluid dynamic and aerodynamic, flight mechanics, and more. Airbus is now actively uses advanced computing solution, and they are trying to train, merge with the universities, and then other let's say about partnering quantum technology experts and making some groups to learn through like what you have suggested in making challenges to learn more about this quantum technology and computing. So this is all at this moment I can add in this session, which I have learned. I had gone through their websites, and then I have learned what they are doing into aviation. Other than that, our engineering pathways are totally different than what we are discussing here. I think it will take, however, whether we like it or not, we have to live with technology. And the students whom we are teaching, they are into hand skills and knowledge. But still, there are certain extent they need to learn about. They need to learn to work with technology when time comes, especially in the aircraft avionics section. What I feel. And we are facilitating them in a very, very smaller scale, like using virtual reality, augmented reality to learn certain repairs, certain facilities which cannot access directly. They are doing this kind of trainings. But in advance, in future, I think we have to analyze how to bring them into this kind of technology in learning. This is a big task for us, but still we will learn more and get it done. And whatever the extent that it is possible for in our sales area, our field of training. Hello?
Yes, ma'am. Yes, ma'am. Proceed, ma'am.
Yeah. So this is what at this moment I can discuss. And yeah.
Thank you very much, madam.
Thank you. Thank you so much, ma'am.
Thank you very much. Thank you.
I think we have come to a concluding session. It is my duty to conclude the session by mentioning few of the applications with respect to quantum technology. Quantum superposition states can be very sensitive to a number of external effects, such as electric, magnetic, and gravitational speeds, as rightly mentioned by our chief guest, rotation, acceleration, and time, and therefore can be used to make a very accurate sensors. Efforts are being made to engineer quantum sensing devices that are cheaper, easier to use, more portable, lighter, and consume less power. If successful, this is expected to lead to multiple commercial applications, such as monitoring of oil and gas deposits or in construction. The next we'll move on to the next application, secure communications. Is another important and very, very futuristic technology. People are using communication for all their field of specialization. So quantum plays vital role in this communication era. Quantum secure communications are methods which are expected to be quantum safe in the advent of a quantum computing system that could break current cryptography systems. Another technology in this field is the quantum random number generator used to protect data, especially, it is the right time to protect our data, especially in banking sector and other important sector. This produces truly a random number without following the procedure of the computing algorithms that merely imitate a randomness. The last important application, this is going to be the future of the quantum technology, the computing technology, computing field. The quantum computers are expected to have a number of important uses in computing field, such as optimization and machine learning. They are perhaps best known for their expected ability to carry out source algorithm, which can be used to factorize large numbers. An important process in the securing of data transmission. So I strongly believe the quantum technology is a ocean. It is very difficult to cover the full topic within that 2-hour session. However, with the help of our chief guest and all the panelists, we could able to understand some information with respect to quantum technology. So if time permits, we will meet again with the same topic so that we can have much more deeper discussion on this same topic. With that, I sincerely thank all the panelists for accepting our invitation and take part in this panel discussion on quantum technology. My sincere and special thanks to our chief guest, Professor Pan, for his wonderful and inspiring speech, and by making the entire session a fruitful one. And it is my duty to thank the pillars of CWSIR, Dr. Smita Tiwari, founder CWSIR, and Dr. Abhishek Pandey, president of CWSIR. He is supposed to give a small talk on today's topic, but due to want of time, he could not able to take part in today's discussion. Maybe we will have one more session with this enlightened speech in this forum. And I once again thank all the members of CWSIR for their constant support and encouragement, for making such a wonderful platform for different topics to get to know various experts' speech and their views on this. With that, I once again thank you all. Before closing the meeting, I would like to welcome all the people to switch on your videos so that we can capture the group photo in this virtual mode. I request all the panelists few more people. Smile, please. Thank you so much. Thank you once again for all the people over here. We will meet again.
And सबसे पहले I would like to be very, very thankful and grateful to my Guruji, Professor M.M. Pant sir, and thank you for his precious time today with all of us. We have learned a lot of things regarding quantum technology by his inspiring and insightful talk, and हम लोग और भी सर को सुनेंगे because this 30 minutes will not be very much sufficient to learn about quantum technology if Professor M.M. Pant is speaker, because he is like an ocean. Not for me, for all the educationists. When I was discussing about Professor Sir to Dheeraj Mehrotra sir, he is the director of CWSIR, and even the honorary patron and the vice president madam also, they all were admiring me in Professor Sir, and they all were, very much, excited to listen about quantum technology if it is talked about. Especially Professor M.M. Pant sir. Thank you very much, sir, for being with us.
Thank you. All the best. Yashasvi Bhava.
Thank you, sir. Thank you so much.
Thank you. Have a nice day.
Thank you very much.
Good night.
Thank you. Thank you.